Good evening, this is Mr. Cockbrenner, and today we will be doing factoring polynomials by factoring out the GCF and factoring by grouping. Alright, so today's objective is factor polynomials by using the greatest common factor. So what we like to call the greatest common factor is the GCF. Let me go back to this. That factor, what does factor mean? It's a fancy way of saying what? Addition, subtraction, multiplication, or division. What does factoring mean? Yeah, it means multiplying, all right? So it's a fancy way of saying multiplication. Again, you know what I love to say. All we do in this class is add, subtract, multiply, divide, and graphing. So here's the deal. We're going to be multiplying and dividing because the opposite inverse of multiplication is division. So ready? Greatest common factor is what's the largest number or factor that they have in common, because I guess there's going to be also letters that they can have in common as well. All right, so we're looking for the largest factor multiplier that they have in common. So a few things we're going to look for. Look first, 2 terms or 3 terms. We're going to treat those the same way, factor out a GCF. If it's 4 terms, we're going to factor by grouping. And then if you have parentheses, it's going to be pretty obvious because they're going to have common parentheses called common binomials. All right, so the first thing I see is 2 terms. So 2 terms means I just factor out the GCF. So the couple tricks. Number 1, the first term has to be positive. All right, so that lead coefficient from last terminology, from last lesson, has to be positive, which it is. So then I'm going to look at these coefficients, and notice how I didn't take that negative because I don't worry about the signs anymore because that first term was positive. So now I'm going to say, hey, what's the greatest common factor between 8 and 12? So here's the thing. 8 can't be greater than 8, all right? So over here to the right, I'm just going to list the factors of 8. What's 8 divided by 1? Good. 8. What's 8 divided by 2? 4. That's all we have for the factor friends of 8. So there's only 4 numbers that it can possibly be, the greatest value being 8. The second greatest value is 4. Then 2 all the way down to 1, all right? So the greatest 8 can be, again, is 8. Does 12 divisible by 8? Is 12 divisible by 8? No. So I'm going to cross that one off the list. Is 4 divisible by, or is 12 divisible by 4? Of course, that's 3. So what I'm going to do, and I'm only going to show it for this example, 2 times 4, and then negative 3 times 4. I'm going to break those into the factor friends, all right? And I'm going to show you why I do that here in a second. So what do they have in common with the x's? What does x to the 4th mean? Well, it means x times x times x times x. And then x squared over here just means x times x. So how many x's do these 2 terms have in common? Hint, it's the smaller of the exponents, all right? So right now, I said we had a 4 in common, and we have 2 x's or x squareds in common. So the reason why I break it down like this in expanded form is just to show you. I'm going to factor these out, divide them out, and that was my 4. And now I have 2 x's from the first term, my 2 x's from the second term. Now what's left over goes in parentheses. What's left over here? 2 times x, or 2x squared. And then what's left over here is just negative 3. So what I did was simplify those 2 terms, those binomials, right? And factor out what they have in common. So again, I can check this by distributing because that's what we see with parentheses. 4 times 2 is 8. X squared times x squared is x to the 4th. 4 times negative 3 is negative 12. X squared tags along. I'm back to where I started with. So that is going to be my simplified form, or what we call factoring out the GCF. All right, here we have 6x and 20x cubed. So again, I look at my coefficients. Actually, I look to see if this is positive first, which it is. 16 and 20. What's the greatest 16 can possibly be? That's where we're going to start with that. 16 divided by 1 is 16. 16 divided by 2 is 8. 3 does not go into 16 evenly, but 4 does, because it's 4 times 4. So now I'm going to always try the greatest factor. 16 can be my smaller of my coefficients. Does 20 divisible by 16? No. Is 8 divisible, or is 20 divisible by 8? No. Is 20 divisible by 4? Show is. So I'm going to keep that as my greatest common factor. And then I'm going to look at my x's, and I say, hey, I have x to the first here, x cubed. So as many x's as I can take from each is 1. Now what's left over? Again, I'm not showing the expanded form. I'm just going to divide out right here. What's 16 divided by 4? 4. I took an x away, so that x is no longer there. What's 20 divided by 4? Positive 5. I have 3 on the top. I have 1 on the bottom, so I'm going to be left with x squared on the top. All right. The reason why I did the expanded form in this last problem was just to show you how it breaks down and then what's left. I'm just going to show you with division here, and the next time I'm just going to do it in my head. All right. So again, if you need help, go back to the slide, listen to that explanation again. Look at this one. Stop, pause, rewind, all that good stuff. So now, again, first term is what? Positive. So I get that check mark out of the way. It has to be positive. Okay. The next thing I do is 8 and 7. Ooh, 7's a special number. What is 7? 7's a prime number. So it's only going to be 1 and 7. So the greatest number or value that 7 can be is 7 to 7. Or is 8 divisible by 7? No. But we know everything has a factor of 1 in common. So now we're going to say, hey, there's 2 C's here. There's 1 C there. This is C times C. This is just C. So they do have a C in common. What's left now? If I just divide this by C, both terms, because I'm going to take from both, I get 8C plus 7. All right. Again, I can check this by distributing in. And of course, 8C times C is 8C squared. 7 times C is positive 7C. All right, so here's a factor that we look. The very first check is always, is it positive? So we're going to factor out that negative right away. We know that that's going to be my answer. Now I have 12 and I have 20. So again, I'm going to list the factors of 12, and 12 has a lot of factor, friends. 1, 2, 3. What's 12 divided by 1? 12. What's 12 divided by 2? 6. What's 12 divided by 3? 4. So as you can see, this has 6 sets, or 3 sets, 6 total factor, friends. So I'm going to look. Is 20 divisible by 12? No, so I cross that out. Is 20 divisible by 6? No, I cross that out. And we know from the last example that 4 does go into it. So I'm going to factor out 4. And then I'm going to say, hey, here's an A. Does this second term have an A? Nope. So they don't have an A in common, greatest common factor. This has B times B times B, or 3 B's. And then this has 1 B. So we know that we are going to get what? 1 B in common. And now what's left? Negative, or 12 divided by 4 is 3. A, B squared. And then positive, let me just erase this so I can give myself a little bit more room. What's left here? Positive 5. Oops. And that's it. Because 20 divided by 4 is 5. B divided by B is nothing. There's 1, I should say. So now I can check this again by distributing. I'm not going to waste your time. Trust me. And here's a 3-termer. Same thing. The first term has to be positive, which it is. And now I'm going to look at my coefficients. It's the same exact process. 6, 15, and 3. What's the greatest or the least or smallest coefficient there? Is 3. 3 again is a prime number, so 1 times 3. The greatest value 3 can possibly be is 3. So let's see if 6 is divisible by 3, which it is. Let's see if 15 is divisible by 3, which it is. So we know we have a greatest common of 3, or greatest factor of 3. I'm getting ahead of myself with my parenthesis there. This has 4 x's, x times x times x times x. This is x times x times x. And this is x times x. So the shortcut is look at your least amount of exponents there, and that's x squared. So I'm going to factor out an x squared. What's left over? What's 6 divided by 3? 2. X to the 4th divided by x to the 12th is x squared. 15 divided by 3 is positive 5. I'm taking away 2 of those x's, so I just have x. And then what's 3 divided by 3? 1. What's x squared divided by x squared? 1. What's 1 times 1? Positive 1. So this is the tricky one, and the reason why I chose that one is because we still need to hold this place value back here. So when we distribute it back in, we can check our work. What's 3x squared times 1? 3x squared. So we're going to keep that value there. All right, so my final answer should look like that. This is our first 3-termer. Here's our second 3-termer. Again, remember that first term cannot be negative, so I'm going to factor out a negative, which just means change the rest of the signs, all right? So when I do that, I'm going to do my shortcut. I have 5, I have 35, and I have 30. Obviously, the greatest number 5 can be is 5. Again, another prime number. 1 times 5 is the only way to get those two friends to make 5. So are all these divisible by 5? If that ends in a 5 or a 0, we're good, which they both do. So I know my greatest common factor as far as the coefficient is 5. Again, my shortcut, if they're the same letter, look for that least amount of exponents, which was x cubed. So I'm going to take that out, and by take that out, I mean divide it out. What is negative 5 divided by negative 5? 1. I have 5 x's here, I have 3 x's here, so I have x squared left over of that first term. That's all that remains. What is 35 divided by negative 5? Negative 7. Again, this was positive, now it's negative because we took out this negative, and that was first term was negative, now it's positive. So you can see how that changes the sign. I'm taking 3 x's away, so if I had 4, I have 1 left over. What is negative 30 divided by negative 5? Gets me positive 6. How many x's did I take? 3. I had 3, so here's my final answer. All right. Again, if this is too quick, pause it, rewind it, and make sure that you understand it. If you don't, please email me. I'm not ignoring you, I promise. All right, so here's the first step. We have 4 terms. So what we are going to do is make this 2 GCF problems, essentially. We're going to look at these 2 terms and factor out a GCF. And we're going to look at these next 2 terms, term 3 and 4, and factor out a GCF between those 2. And then we're going to see some magic happen. That magic's called algebra, and we're going to get not 1, but 2 terms in common. So what do 7 and 2 have in common? They don't have anything in common because 2 only goes into even numbers and 7's not even. So now let's look at our exponents. We have p to the 4th and p cubed. I'm going to take 3 p's out, right? P times p times p. So I'm going to take those out of these exponents in expanded form, and I'm going to be left with 7p minus 2. Because when I divide out, remember, factors are multiplication, so the inverse of multiplication is division. I'm going to get left with that. So the trick is when I do these 2, this term 3 and term 4, I should get 7p minus 2 in these parentheses here, all right? So let's just say, hey, 63 and 18, let's do our trick. Is the first term positive? Yep. Now 18, how many factor friends does 18 have? Just count 1, 2, 3. What's 18 divided by 1? 18. What's 18 divided by 2? 9. What's 18 divided by 3? 6. So it has 6 sets of friends, or 6 total friends, 3 sets. Does 18 go into 63 evenly? No. So that's out of the picture, 18. Does 63 divided by 9 work? Yep. So that's your greatest common factor, all right? Between 63 and 18 is 9. So I'm going to factor out a 9. And are there any p's to factor out here? No. And again, what is 63 divided by 9? It's 7. What's left? That p. So I'm going to divide this by 9 and this by 9, and I'm going to get exactly what I told you to look for. You're going to get these parentheses that you have in common. That's what we call a common binomial. Again, if you remember from last lesson, binomial means two terms. So this doesn't have just one term in common like the 2-term and 3-term problems did. These actually have 2 terms in common. So what you're going to do is anytime they have something in common, it goes to the front. 7p minus 2. And remember how we scribbled those out? If we scribble this out and scribble this out, what's left over? My favorite holiday is Thanksgiving leftovers. So what's left over goes in parentheses behind it. I get p to the third plus 9. And that is my answer. All right. Again, this is not easy, so we're going to have to show you one more of those. So let's go. We have how many terms? 4 terms. So we're going to group these factor by grouping. Remember, what's a term? Number, sign, number, letter. So I'm going to factor this negative with the 6x. So now what do 2x cubed and x squared have in common? Is my first term positive? Yes, so that's good. 2 and 1. The greatest number 1 can be is 1, so let's hope they have some exponents in common, which they do. I'm going to take out an x squared, or x times x. What's left over? 2x, when I divide this out, right? What's x squared divided by x squared? Positive 1. So now, because I did all that hard work, I know what should be in these parentheses if I did my work right. All right? So it should be, we can kind of like dot it in. It should be a 2x plus 1. All right. So ready? What's the first term have to be? First term has to be positive. Is negative 6x positive? No. So the first thing I have to do is factor out a negative. Again, it's basically 2 GCF problems. Problem 1, which we just did, and problem 2, which we're doing right now. So I factor out a negative. Now I have 6 and I have 3. Let's break down the smaller of the value because the greatest number 3 can possibly be is 3. It's prime. Guess what the GCF is? 3, because 6 divided by 3 gets us our 2, so that works. Now what is negative 6 divided by negative 3? Positive 2x. That's what we said was going to happen. What's negative 3 divided by negative 3? Positive 1. And what do you notice is happening over here? It's pretty obvious. We're getting what? Common parentheses, 2x plus 1. They have this in common, right? It doesn't look like it says plus 1 over here. It looks like it says plus 4. And this x is kind of funny. Sorry. My writing looks bad. I'm just fixing it. All right, so since they have that in common, what's left over? This GCF and this GCF. The GCF from this part and the GCF from this part, that goes in the back. X squared minus 3. All right, so that is going to be our final answer. All right, so here is the parentheses problem. What do they have in common? Right away, you notice what? The parentheses. Yeah, so they have a common binomial as well. Now what's left over? The GCFs. They already did the hard part for us. They did the 2 problems. Now they're just saying, hey, 3y minus 5. You see where I got those from? So the parentheses are really, really quick. If it's too quick, we're going to do another one, which is the complete factorization of this. So ready? Again, what's given? You have parentheses, x plus 4 and x plus 4. So you know x plus 4 is going to be in your answer. So the only one that says x plus 4 in your answer is what? A. And guess what your answer is? A. How'd you get that? Because when you have it in common, you have it right here. What's left over? What's left over is going to be 9x minus 5, which says 9x minus 5. Normally it's this way, where the x plus 4 gets pulled to the front and 9x minus 5 goes to the back. But with multiplication, what's 5 times 3? 15. And what's 3 times 5? 15. It doesn't matter their order because they're factors, they're multipliers, all right? What is the GCF of these binomials? So these are 2 terms. What do 6 and 5 have in common? Right? Always start with your smaller coefficient. So again, one's a prime number. Does 6 divided by 5 work? Nope. Does 6 divided by 1 work? Of course it does. So now we're going to go to our exponents here. X cubed and x squared. Again, it's always the smaller exponent that they have in common. So they have an x squared in common, right? So that's A, B, C, or D. And it looks like it's C. All right. If we were asked to factor the rest of it out, it would just say what? 6x plus 5? If we had that as an option to factor completely out, which we don't. They're just asking us for the GCF, the greatest common factor, which is what you are pulling to the front and simplifying. Now here's a question. It says, what set of numbers has a GCF less than 10? So again, you have 12 and 60. What's smaller? So the greatest value 12 can be is going to be 12. You know that. I just like to count 1, 2, 3. What's 12 divided by 1? 12. What's 12 divided by 2? 6. What's 12 divided by 3? 4. So I always start with the greatest number 12 can be is 60 divisible by 12. Yep. So this is going to be 12. Is that less than 10? Nope. So we know it's not going to be A. How about B? 14 and 49. What's the smaller value? 14 or 49? So let's list the factors of 14. Let's just count 1, 2, and 3. 14 divided by 1 is 14. 14 divided by 2 is 7. 3 doesn't go in, so we know that's not going to work. Try 4, try 5, try 6. Now we're back at 7 already, so we know that these are only my factor friends are 1, 2, 7, and 14. So let's try 14. Is 49 divisible by 14? Nope. Is 49 divisible by 7? Yep. So we know that this is less than 10. So we're going to keep this one around. Let's just try 55. 55 and 121. Obviously, 55 is a smaller value between there. 1, 2, 3, 4, 5. We'll go up to 5 this time. What's 55 divided by 5? Or divided by 1 is 55. 55 cut in half won't work. 55 divided by 3 will not work. 4 won't work. 5 gets you 11. So let's go with, is 121 divisible by 55? Nope. Is 121 divisible by 11? Yes. So I have 11 here. Again, I had 7 here. And I had 12 here. We are looking for things that are less than 10. So right now, we know that A is not going to work, as well as C is not going to work because that's 11. And our last thing we need to try is 30 and 45. What's the smaller value? So the greatest 30 can be is, just count, 1, 2, 3, 4, 5. 30 divided by 1 is 30. 30 divided by 2 is 15. 30 divided by 3 is 10. 4 doesn't work. 30 divided by 5 is 6. So those are our factor friends right there. Does 30 go into 45? No. Does 15 go into 45? Yep. So my GCF here is 15. So I had to work out A, B, C, and D. And I see that the only one that's less than 10 is B. So B would be my answer. All right. So again, that's factoring polynomials by GCF and grouping. I think the most work is probably the 4 terms, but it's just 2 separate problems. Factor out the first GCF, the term 1 and term 2, factor out the GCF between term 3 and 4, and guess what? You're going to get those common binomials. Not so bad. All right, let's not be sad. Other than that, if you liked the video, subscribe. Give me a thumbs up. Other than that, you enjoy your evening. If you need something, let us know. Shoot us an email. We'll help you out as best we can. Have a great one.